Good day, students. Today, I want to talk on the topic titled Transformer. Transformer is an electrical device for changing the size of an AC voltage. It either increases or decreases the EMF of an alternating current. That's the work of transformer. Whether we have step up transformer and also we have step down transformer. In the step up transformer, you have in the primary coil we have the lesser coil, while in the secondary coil we have more turns of the coil. But in the step down transformer, we have more coils, more turns of coil in the primary, and we have lesser coil in lesser turns of coil in the secondary. That's step down transformer. Okay, what is mutual inductance? Mutual inductance is the flow of an induced current or voltage in the coil due to the varying alternating current in the neighboring coil. That's mutual inductance. And let's see, a transformer is an electrical device for changing the size of an AC voltage. It acts to increase or decrease the EMF of an alternating current. Okay, now if you want to decrease the EMF AC voltage, you have more turns in the primary and lesser turns in the secondary. That's step down transformer. But if you have more, you need more voltage, you have more turns in the secondary and lesser turn in the lesser coil in the primary. Is that okay? That's a step up transformer. Okay, mutual inductance. It is the flow of induced current or voltage in a coil due to an alternating or varying current in the neighboring coil. When voltage current is being supplied, when current is being supplied to the secondary, to the primary, and when it's being supplied, because of the magnetic flux being created in the soft iron core of the primary coil, it will now be transferred to the secondary coil through mutual inductance. That's why I say the flow of induced, it will be induced. Current or voltage will be induced in the secondary due to the flow of current in the primary. That's mutual inductance due to the alternating or varying current in a neighboring. This is the neighboring coil to the secondary. Is that okay? Now, step up transformer, you can see that you have lesser turns of coil here in the primary. We have more turns of coil in the secondary. That's step up transformer. See, laminated soft iron core. NS, the secondary coil has number of turns. That's NS is greater than NP. Okay, that's step up transformer. This is the primary coil. The ratio NS over NP is called the turns ratio of the transformer. Don't take it for granted. NS, please be observant. NS is at the numerator, NP is at the denominator. Is that okay? But when you get to the current, it will be up the reverse. IP will be up, IS will be down. But when you talk about EMF, it will be ES over EP, NS over NP. But when it gets to current, it will be IP over IS. IP over IS. The ratio NS over NP is called the turns ratio of the transformer. It is more than 1 for a step up transformer and less than 1 for a step down transformer. What you are seeing is that the formula for transformer number of turns, when you want to get the turns ratio is always NS over NP. When you have step up transformer, you see that you have more turns in the secondary. It will not be, let me say you have 3 over 1. Can you see that it's more than 1? But when you have lesser turn, that's when you have more turns in the second, that is step up transformer, 3 over 1, that's equals to 3. But when you have step down transformer, you still have ns over np. Let me say it will not be reversed. Let me say ns is now 1 and np is now, that's step down transformer 3. See that it's less than 1. It's less than 1, which is 0.33. Is okay? That's what you are saying, that it is more than 1 for a step up transformer, that's the turns ratio, and less than 1 for a step down transformer. Efficiency of a transformer equals output power over input power times 100%. Efficiency of a transformer equals power in the secondary. Please take note, power in the secondary first over power in the primary. That is output. This is output and this is the input. The others write as output power over input power, or power in the secondary over power in the primary times 100%. 100% shows that it's an efficiency. Is that okay? Now, secondary EMF ES over primary EMF EP equals number of turns in the secondary over number of turns in the primary equals the current in the primary over current in the secondary. See that it's being reversed when it gets to current. Please take note. Now let's see example. Find the number of turns in a transformer which delivers a voltage of 120 volts in the secondary. You can see it. E secondary, that's 120 volts in the secondary from a primary voltage. We have primary voltage, the value for primary voltage here. Let's take it to be 60. High voltage. Find the number of turns in the secondary. We deliver a voltage of 120 volts in the secondary from a primary voltage 60 volts. Now EP equals 60 volts. Okay. Now don't forget that we are looking for turns ratio. Turns ratio. Turns ratio, which is equals to AS over EP equals to NS over MP. Okay, and also when you want to write the current, IP over IS, you reverse it. But we are concerned with this, which is turns ratio NS over MP equals what our ES 120 volts over 60 volts, which is 2. Turns ratio is 2. This is the end of our class. Please subscribe to my channel so that you can have access to the latest video. Have a wonderful day.